Welcome to Data and AI with Varath. On this channel, we break down complex topics into clear, practical explanations. Every dashboard, every report, and every AI model depends on one critical function working quietly in the background: data engineering. Before insights can be trusted, before decisions can be made, and before automation can scale, raw data must be collected, cleaned, transformed, and delivered reliably. That responsibility belongs to data engineers. In early systems, data lived in a few databases. Reporting was simple and workloads were predictable. But as businesses grew, data started coming from everywhere. Transactional systems, applications, logs, APIs, third-party platforms, and cloud services. Suddenly, moving data manually or writing ad hoc scripts was no longer sustainable. Data engineering emerged to solve this growing complexity and make data reliable at scale. At its core, data engineering is about trust. Trust that data arrives on time. Trust that numbers are accurate. And trust that systems will scale as data volumes grow. Data engineers build pipelines that move data from operational systems into analytics platforms in a structured and repeatable way. Data engineering did not start in the cloud. In many organizations, it began inside databases. Stored procedures moved data from one table to another. SQL Server agent jobs ran nightly batches. This worked when data volumes were small and systems were centralized. As data grew, tools like SSIS emerged. SSIS allowed teams to build reusable ETL pipelines, manage dependencies, and handle errors more gracefully. For many years, SSIS powered enterprise data warehouses. Then the cloud changed the rules. Data sources multiplied. Data volumes exploded. Systems became distributed. Tools like Azure Data Factory introduced cloud-native orchestration. Pipelines could move data across regions, platforms, and services. Databricks enabled large-scale transformations using distributed compute. Modern data engineering combines these approaches. The goal is no longer just moving data, but building reliable, scalable pipelines that can adapt to changing business needs. Operational systems are optimized for transactions. They record orders, payments, and updates quickly, but they are not designed for analytics. Running complex queries on OLTP systems slows down the business. This is where ETL creates real business value. Data engineers extract data from OLTP systems, transform it into analytical structures, and load it into data warehouses or analytical platforms. This separation protects operational systems while enabling deep analysis. Without ETL, analytics competes with production workloads. With proper ETL, the business gains insights without risk. As data platforms evolved, so did storage patterns. Data warehouses provided structured, governed reporting. Data lakes enabled storage of raw and semi-structured data at scale. Lakehouse architectures combine both approaches. Data engineers design pipelines differently depending on the platform. Warehouses prioritize schema and consistency. Lakes prioritize flexibility. Lakehouses aim to balance governance with scalability. Understanding these trade-offs is a key responsibility of modern data engineering. Modern pipelines are not simple scripts. They include validation, monitoring, retries, and alerting. Failures are expected, and pipelines must recover automatically. Data engineers design systems that run every day, often without human intervention, while still providing visibility when something goes wrong. Mendelian Architecture emphasizes separation of concerns. Raw data is preserved exactly as received. Transformations are applied in curated layers. Consumption layers serve analytics and reporting. This approach improves traceability, simplifies debugging, and ensures that data transformations can be reproduced reliably over time. Data engineering is the foundation of analytics, reporting, and AI. Without reliable pipelines, even the best models and dashboards fail. Strong data engineering ensures data arrives on time, at scale, and with trust. In the next video, we will explore how analytics and BI teams use this engineered data to drive business decisions. Thank you for watching. If you found this video helpful, please like, share, and subscribe. More data and AI explainers are coming soon.